So let me give you a short, this is a part one on crash course in electrochemistry, and you might be able to see this, this equation that, okay, copper and the zinc together, and they can form an ion, and then the way that it works is zinc is oxidized into zinc 2 plus, so this is an oxidation, and this is a one that is going to be reduction. Okay? So this is a way that what we call the spontaneous. As you remember the thermodynamics, spontaneous means delta G is a negative. In the electrochemistry people, they use a standard cell potential that is a positive. Okay, so this is all related to the quantities, and so this means that this reaction is a spontaneous, and this reaction is always moving forward. So you can see that there is a couple of 2 electrons here. This is essentially stolen by the copper, and you can get the clue from here, from electronegativity. So let's have a look at the zinc here. Zinc is 1.6 electronegativity. Where's the copper? Copper is 1.9. So which one is more electronegative? Copper is more electronegative. So therefore, copper would like to steal the electron from the zinc. And so that's why it is showing in these fashions. And we have a bunch of other one. And if you can see that actually, if you look at this, the gold is very electronegative in this among the metals, right? So that's why the gold is the one who likes to keep the electrons, and that's why it's hard to oxidize a gold, and therefore gold get never rusted, right? Gold is remaining shiny metal because of it is a high electronegativity. So electronegativity is an extension of what you guys learned in the chemistry 1, and unfortunately, this is not sufficient all the sufficient information for us to understand, which one will be reduced. The one with a higher electronegativity will be the winner for competing the electrons, so that they can get reduced. However, we need a better, because sometimes there are more complicated electrochemistry, something that chemistry reaction involved with the transfer of the electron, and that's so on. So what electrochemistry community decide to do is they actually develop this, what is called standard electrode potential. Okay, this is this name actually a little bit ambiguous, but that's the way that it's been used. So this is what you guys see from your reference sheet in your exam, standard electrode potential, and they have to designate what temperature it is, and then they write a small thing called a reduction half reaction. So this is a collection of the reduction half reaction for this bunch of the reaction that you guys see, and this is essentially what we need to use for the one. And here I essentially give out some collection of a few examples here. So what you see here is one thing that I wanted to emphasize is this standard reduction potential is actually, I love to call it as a standard reduction potential. So this is a standard reduction potential, they write it. And if I were you, I will actually rewrite this number as standard, which means not, and RED. So this is a reduction potential for that particular one. So this is the way that the electrochemistry people decide to do is they write the half reaction, and all the reaction that you see here is a reduction reaction, right? So all the ions this is all reduction reactions. So this is what you need to know. And then let me go show you this. So when the Ag, which is a silver ion, gets the electron to get reduced, they get silver shiny metals. Copper gets to 2 electrons, they can be copper. So does the other one, right? So these are the one that you guys can see. These are lithium and so on. So this is they list this one to give you the example. And the one thing that to give you a reference point is this one. So think about you are doing this electrochemical reaction, and this is happening in the water, and all you put it is on just an acid. And the acid, when they get reduced, you get the hydrogen bubbles that come out, and so that's the standard potential for the reduction. And they need a reference point, and this is your reference point where people decide to put the zero electrochemical potential there. And the way that I like to call this is I'm going to make a thick one here, and this is a way. So when they're competing for the electron, this I'm going to write the arrow this one, and I'm going to write this way. This one wins. Whichever going to be on top, they're going to win. Okay, so let me choose this. When you have a silver and when you have a zinc, when they're going to compete together, which one wins? Silver wins. Right? So this is a one that we're going to keep it this way, and this one going to be the reverse. Okay, this is too thick. Okay, so we're going to have a reverse reaction, which is let me put up different colors. So this is a keep as it is, which means a reduction, right? So we're going to do this way reduction, but whereas this one is a reverse, which means an oxidation. This is a concept that will show up in many of the problems. We're going to certainly talk to you about that here. So once again, the list of the standard reduction potential, you guys can easily find out from this reference sheet here, which is going to be used many times through my problem solving. This standard reduction potential, just trying to think about whichever the larger, higher, the bigger value in terms of, they are the one that wins, means a reduction wins. Okay, this reduction you choose, the last one will do the reverse, right? Because they lost the battle for the competition of the electrons, so they will do the reverse reaction. We also call oxidation, right? So just keep this one in mind when you're looking at this, because this is really the hearts of the one that whenever you find it anywhere in the textbooks or exam reference sheet, you will see the standard reduction potential, and then which one is a winner, and then which one is a loser, and then you can set it up the reaction, and that's the way that is what is called a spontaneous reaction. One last one is I want to show you. Oh, this is something happens here. Okay, so this is I guess a PDF conversion issues. I just want to talk about a little bit about Faraday constant. Faraday constant is very, very important concept. Without understanding the Faraday constant, you cannot really do anything about the electrochemistry problem solving. And Faraday is an electrochemist who really study different areas of the chemistry. He has a big research and big accomplishment in the electrochemistry. And what he empirically find out is essentially, if you have a 1 mole of electrons, right? What is the charge of them, right? The collection of one moles of electrons. He find out 96500 coulomb is the 1 mole of electron. And if you actually do the Google search, you'll find out 1 particle, okay, just an individual electron, what's their charges? 1.60 10 to the minus 19 coulomb, okay? And so the correct way of writing this equation above is per mole. So what I can relate it from here is now Faraday constant is essentially charges Q of an electron multiply Avogadro's number. Okay, so this is what I mean by Q of an electron. Okay, if you do that, that's a charge, and for electrons. So it's good to know. Okay, so let me go and having a look at it one more time. This massive table that you see, and even the reference sheet shows that is shown in the box, and then oh,